Hello everyone, welcome back to the channel. I am Nikhil Kumar. Most DevOps engineers today are learning Kubernetes, CI/CD, observability or maybe some cloud certification. But quietly, there is another shift happening underneath all of this. And most engineers still don't realize how big this shift actually is. That is AI infrastructure. And no, I am not talking about becoming a data scientist. I am talking about the systems layer powering AI itself. Because behind every ChatGPT response, every AI agent, every recommendation engine, there is an infrastructure that consists of containers, GPUs, inference servers, distributed systems, and Kubernetes. And the interesting part is, a huge part of this already overlaps with skills DevOps engineers have been building for years. So in this video, I want to show you why AI infrastructure is exploding, where the DevOps engineer fits into this shift, the difference between ML engineer, MLOps engineer, AI infra engineer, and the platform engineer, and why this may become one of the most valuable engineering paths over the next few years. Let's first understand what actually changed. For years, most backend systems were relatively predictable. So you send a request, logic runs, and you get predictable output. Same input, same output. This is deterministic behavior. But AI system behaves very differently. Instead of writing rules manually, we train system using the data. Data goes into the training. Training creates a model, and the model is used for the inference. And suddenly, infrastructure changes completely. Now we have massive models, GPU heavy workloads, huge inference traffic, vector search, and model serving pipelines. And this is where I started realizing something important. AI isn't just a model problem anymore. It's an infrastructure problem too. And once software becomes probabilistic, serving it becomes completely different engineering challenge. Because unlike traditional application, AI systems are constantly running inference workloads at massive scale. Now when people think about AI, most people immediately think about training huge models. But honestly, most companies are not training foundational models from scratch. They are just serving them. Inference is the real production workloads. Because every time a model is actually used, an inference request happens. For every chatbot reply, for every AI agent action, for every generated image is inference happening in the production. And depending on how these predictions are needed, AI system usually inference in two different ways. So first one is the batch inference. Here we process large amount of data together. We take a data set, run it through the model, and generate a prediction in bulk. This usually runs on a schedule, like a nightly fraud detection. But modern AI introduces a completely different patterns, that is a real-time inference. Now instead of processing huge dataset at once, we process requests instantly. A user sends a request, the model runs an inference, and we return a response in a real time. So for every ChatGPT response, every AI autocomplete and every recommendation feed refresh is a real-time inference workload. Now imagine millions of these requests happening every single day. And once you start operating at this scale, entirely different engineering problems start appearing like latency, throughput, auto-scaling, GPU utilization, cost optimization, and observability. And suddenly the problems start looking very familiar to the infrastructure engineers. At this point, this starts looking less like application development, but more like a distributed system engineers, just with models and GPU added into the picture. For years, most backend systems were CPU focused, but AI workloads changed that completely. Modern AI models are massively parallel workloads, and GPUs are optimized exactly for that kind of computation. But once GPUs enter the system, everything becomes significantly more complex. Now we are no longer dealing with the simple application containers. We have a GPU-aware workloads, specialized scheduling, VRAM limitation, resource sharing, inference optimization, and distributed orchestration. So Kubernetes now needs to understand the GPU resources and intelligently schedule workloads across GPU nodes. Now GPU utilization becomes critical because these machines are extremely expensive, and unlike CPU, GPU memory becomes massive constraint. A model may fit on the disk but fail instantly because of VRAM is insufficient. So suddenly optimization becomes extremely important. And this is exactly why AI infra engineering is becoming such a huge field, because once the GPU enters the production system, the infra challenges grows dramatically. Now once companies start deploying GPU heavy workloads at scale, managing everything manually becomes impossible. And naturally this pushes us towards orchestrated systems like Kubernetes. And this is where Kubernetes enters AI infrastructure. Because once models move into the production, they need to be set reliably, scaled efficiently, and managed like a real distributed system. So let's understand with the help of this particular diagram. So user request first enters through the ingress layer. which route traffic inside the Kubernetes cluster. Then the traffic reaches the model serving layer. This is the component responsible for handling inference requests. And behind the scene, Kubernetes can run multiple serving pods parallelly. And this allows the system to scale horizontally as inference traffic increases. And once request volume increases, Kubernetes can automatically scale these workloads so inference system can dynamically handle changing traffic. And models themselves are usually stored separately inside the model registries or artifact storage system. This allows teams to version update and deploy model independently. And this is why Kubernetes became such a huge part of modern AI infra, because AI systems eventually start looking less like simple application and much more like a large-scale distributed platforms. But here's the interesting part. So if you already understand containers, Linux, networking, observability and Kubernetes fundamental, you already have a massive advantage entering into AI infrastructure. Because many AI engineers deeply understand models, but they struggle with the production system, while many DevOps engineers already understand the production system, but they just haven't connected those skills to AI yet. But deploying model is only one part of a modern AI system. The moment companies start building RAG system and AI search, the traditional databases also started becoming a limitation. Because traditional databases are designed mostly for exact matches, but AI system needs a semantic similarity. So instead of searching exact words, we now search by meaning. And this is where vector databases enters. So modern RAG systems work like a retrieval pipeline. So first of all, we take documents like PDFs, logs, knowledge bases and support tickets and then split them into a smaller chunks. Those chunks are then converted into embeddings, which are the numerical vector representations capturing the semantic meaning. And these embeddings are stored inside the vector database. So instead of searching exact word, we can now retrieve information based on similarity and the context. So when a user sends a query, the system retrieves the most relevant chunks from the vector database only after the retrieval. So the model generates a response using the external knowledge, and this dramatically improves the factual grounding, which helps reduce hallucination. And suddenly AI systems now require entirely new infra layers, embedding pipelines, indexing, latency optimization, vector databases and retrieval systems. So AI isn't replacing infra engineering, it's creating an entirely new infra category. And once systems become this distributed with models, APIs, GPUs, vector retrieval and orchestration all working together, debugging becomes dramatically harder. Now imagine debugging an AI system in production. Traditional observability usually tracks logs, traces, latencies, memory and the CPU. But AI system adds entirely new dimension at scale. But this becomes extremely challenging, which is exactly why observability for AI system is becoming a massive field on its own. And this complexity increases even more once we move into AI agent, because agents are no longer single inference requests. They are multi-step system interacting with tools, APIs, memories and the external service. Right now everyone is talking about AI agent, but AI agents are not magic. Underneath, they are still the system. Now, this is where modern AI system becomes even more interesting. AI agents are no longer just a single model request. They are multi-step system capable of reasoning, retrieving context, using tools, calling APIs and making decisions dynamically. So everything starts with a user request. The language model becomes the decision-making core. It decides what information is needed, which tool to use and what action to take. An agent may also maintain memory, which helps preserve context across interaction. This allows system to behave more intelligently over the time. So then the agent can interact with tools like Kubernetes clusters, search systems, terminals, databases or external services. So the model is no longer just generating text, it's interacting with the system. And many agent also connects to APIs and the vector databases, which allows retrieval, external integration and access to real-time information. And once system becomes dynamic, observability becomes critical, because now we need to monitor tool calls, latency, cost, reasoning chains, errors and the system behavior. And finally, the system generates a response or performs some action, but behind that response, multiple systems are working together. So AI agents are not magic. They are distributed systems built on the top of models. And this is exactly why new engineering roles starting emerging around AI system, because building models, serving models and operating AI infrastructure are completely different challenges. Now let's quickly clarify the different roles, because this confuses a lot of people entering AI system. And honestly, these roles often overlaps in real companies. But understanding the layers helps you understand how modern AI systems are actually built. So first of all, we have a ML engineer. Everything usually starts close to the model itself. So ML engineer focus more on models, training, experimentation, and feature engineering. So they spend most of their time improving model behavior and performance. Then comes the next challenge. How do we manage these systems into the production reliably? And this is where MLOps engineers usually operate. They focus more on reproducibility, deployment pipelines, experiment tracking, and model lifecycle management. They help bridge the gap between the experimentation and the production system. But once AI workloads start scaling, entirely new infrastructure problem appears. And this is where AI infrastructure engineer usually comes. They focus more on GPUs, Kubernetes, distributed inference system, sovereign architecture, scaling, and optimization. And this is the layer where infra engineering and AI workloads started deeply merging together. And finally, the platform engineer focus on enabling the entire ecosystem. They build the internal system and platforms allowing teams to operate at scale. This includes internal tooling, developer platforms, automation, security, and the operational consistency. But in reality, modern AI systems require all of these layers usually working together, because building models is one challenge, but operating AI system at scale is another challenge. This is exactly why DevOps and AI infra engineers are extremely valuable in the AI space, because AI systems are no longer machine learning problems, they are the distributed system problems too. And when you look closely at these roles, something very interesting becomes obvious. A huge part of AI infrastructure already overlaps with skills DevOps engineers have been building for years. A lot of engineers today are still learning AI from the application side. They are learning prompting, building wrappers, creating chat application. But infra side still has a massive talent gap. Company needs engineers who understand Linux, containers, Kubernetes, observability, and the networking, and can apply those skills to the AI workloads. And honestly, this is where DevOps and platform engineers already have a huge advantage, because AI world now suddenly need the people who understand systems at scale. Which means DevOps engineers are actually more closer to an AI infrastructure than they realize. And I think over the next few years, it's going to be one of the most valuable engineering intersection in the industry. So in this series, we are not going to approach AI like isolated notebooks. We are going to approach it like a system engineering. We will understand training versus inference, reproducibility, machine learning pipelines, containers for machine learning, Kubernetes for AI, vector databases, rack system, observability, and the AI agent. And we will build this system step by step, starting from fundamentals and slowly moving towards the production scale architecture. Because AI is not just a model anymore, it's an infrastructure. And this shift is only getting starting. If you found this video helpful, hit like, share it with your friends, and subscribe for more content like this. Thanks for watching. I will see you in the next one.